Alright, so you have in your notes the half-angle identities. So now we're going to apply those to an actual trig function itself for a trig value. So this example 2 says use a half-angle identity to find the exact value of each function. So we're going to start off with A, which is sine 7 pi over 12. Now the first thing to understand and recognize is that if you look at 7 pi over 12, there's nothing on our chart that we've talked about over and over and over again, that we've looked at over and over and over again, that is 7 pi over 12. So when we actually are going to do this problem, we need to get it to a point that we're actually going to have a value from our chart. So in order to do that, what we will always do, always, every single time, we'll take this angle and multiply it by 2. If it's a degree, we multiply it by 2. If it's an angle, if it's a radian measurement, we multiply it by 2, but we always multiply it by 2 first. So we're going to do 7 pi over 12 times 2, and we're going to multiply and simplify it down. So we're going to cross reduce that. That'll give us 7 pi over 6. Cross reduce it, give us 7 pi over 6. Alright, so we're going to look at sine 7 pi over 6 divided by 2. Because as we looked on the last screen, or as we looked at the notes itself, when it comes to the sine half angle, or the half angle identities, it's always the trig function and then theta over 2. Whatever theta is, that goes on top, and we always divide it by 2. So we said theta here is going to be 7 pi over 6. So when we do this, we're going to deal with 7 pi over 6 as our theta. So we're going to look at 1, I believe it's plus cosine. Yeah, I'm sorry, I'm wrong. It's minus cosine theta over 2. So we don't have cosine here. We have sine, but we don't have a cosine. But how do we find cosine with really kind of no values that we understand? Well, if you remember exactly what I said seconds ago, this is our theta right here. So we substitute that into that part there and solve it out. So this is going to be 1 minus cosine 7 pi over 6 divided by 2. Now the question is, what is 7 pi over 6? Cosine 7 pi over 6. And as we did in class, as Bessie said in class today, it's going to be 1 minus a negative square root of 3 over 2 divided by 2. So make sure you remember that chart. Make sure you study that chart. Make sure you know it. Not just remember the values by looking at it. Alright, so with this, we're going to go ahead and combine them. So we have 1 plus the square root of 3 over 2, all divided by 2. Simplify this down all the way to the bottom. So we're going to go ahead and get these two, the whole number and a fraction together. So it'll be 2 over 2 plus square root of 3 over 2, all divided by 2. Combine those fractions on top. That'll be 2 plus the square root of 3 all over 2, all divided by 2. And then here, we're going to go ahead and combine these fractions. That's 2 plus the square root of 3 over 2 times 2, flip that thing, that gives us 1/2. So we're looking at the square root of 2 plus square root of 3 over 4. And then here we have to take the square root of the top and the bottom. So that'll be the square root of 2 plus the square root of 3 over 2. And that's our final answer. And yes, we can have a radical under a radical. Alright, in class, I told you guys to go ahead and finish up tangent 67.5, do double half angle identity with that one. So in class tomorrow, and the homework, I'll check to see if you did that. Alright, that is the part we did in class today, so we'll finish up the rest of this tomorrow. Alright, take care.